Okay, this is the free body diagram quiz reteach video. For each of the questions below, we're going to make sure that we're doing the following steps. Read the question, draw a box, show the direction and strength of the force acting by drawing an arrow, and then name the forces that we've drawn for each arrow, for example, force applied. Figure out what the F net is for each problem, and put it in the box labeled. Question number 1. Mr. and Mrs. Post were moving a sofa across their living room floor. Mr. Post was pushing with a force of 50 newtons, while Mrs. Post pushed with a force of 30 newtons. Friction with the floor was 20 newtons, gravity and the normal force were 20 newtons each. Create a free body diagram to illustrate the forces acting on the sofa. First step is to draw a box. So there we go. It says that Mr. Post was pushing with a force of 50 newtons. Now it doesn't say which direction he was pushing in, so I'm just going to choose to the right. And that's 50 newtons force applied. Mrs. Post is pushing with a force of 30 newtons, so they are moving the sofa together across the living room, so she gets an arrow 30 newtons force applied. If I wanted to just draw one arrow, I could. One arrow for 80 newtons, but I'll draw them separately. Then it says friction with the floor is 20 newtons, and friction always goes opposite the force applied. So that's 20 newtons force of friction. Gravity and the normal force are 10 newtons each. Gravity pulls down. There's 10 newtons. Force of gravity, normal force counters that. Force normal. And then I'm just going to go ahead and subtract the arrows that are the opposite direction. So 10 newtons up, 10 newtons down, cancel each other out. And then I have a total of 80 newtons going to the right. 50 plus 30 give me 80. And then I take away 20 newtons going to the left. So my net force left over is going to be 60 newtons going to the right. And because I have some net force left over, and it is not zero, the forces are unbalanced, so the object is going to change its motion. Alright, problem number 2. Hot air balloon is sailing through the air with constant velocity. The lift force generated by the burner is 200 newtons. The force of gravity is 150 newtons, and air resistance is 50 newtons. Create a free body diagram to illustrate the forces acting on the balloon while it was in flight. Alright, so going back to the beginning of the problem, it says that there is a lift force generated by the burner that's 200 newtons. So lift force is going up 200 newtons. So a couple of you would put force applied because it's a push or a pull, or if you put FL for force of lift, that would be okay too. It says that the force of gravity is 150 newtons, and gravity pulls down, so I'm going to draw my 150 arrow down, 150 newtons down, force of gravity, and then air resistance is 50 newtons. So here's where some of you messed up. If the balloon is being lifted up through the air, it's moving through the air. So these green dots are supposed to represent the air molecules that it's moving through. So if that balloon is rising, it's being lifted through the air, the air is going to push down on the balloon with a force of 50 newtons. So you could have said force of air resistance, or air resistance is technically a type of friction. So we have a total of 200 going up, and you have a total of 200 going down. 50 plus 150 gives you 200. So 200 going up, 200 going down, they balance and they cancel each other out for 0 newtons of net force, and we would say that those forces would be balanced. Alright, last problem. 2 teams are playing a tug-of-war game. The red team versus the blue team. The red team was pulling to the left with a force of 500 newtons, while the blue team pulls to the right with a force of 400 newtons. There's a slight breeze blowing to the right with a force of 50 newtons. Friction on the ground is 30 newtons. Create a free body diagram that illustrates the forces acting on the tug-of-war game. Step number 1 is to read the question, which we've done, and then we're going to draw a box right there. So the red team is pulling to the left with a force of 500 newtons. So I'm going to draw a big arrow because 500 is a lot. 500 newtons to the left, force applied. And then it says the blue team pulls to the right with a force of 400 newtons. So there's 400 newtons for the blue team pulling to the right, force applied. And then it says there's a slight breeze blowing to the right with a force of 50 newtons. Okay, so there's 50 newtons. You could have said force applied, force of air resistance, force of friction. I would have pretty much taken anything. And then friction with the ground is 30 newtons. So if you messed this problem up, this is probably what you did, or probably where it went wrong. So both the red team and the blue team are pulling on the same surface. So for the blue team that is pulling to the right, force applied to the right with 400 newtons, the force of friction always goes against the force applied. So for the blue team, their friction goes over here, 30 newtons force of friction. And for the red team that's applying 500 newtons of force to the left, their friction goes over here. So I would have 30 newtons force of friction for the red team. So the next thing I would do is add up all the arrows that are going to the left. So I have 50 plus 30, give me 530 to the left. And then I have 400 plus 50 plus 30, give me 480 newtons to the right. So what do I have left over for my net? I take 480 away from 530, and I get 50 newtons of net force to the left, which makes it an unbalanced force.